Hello, I'm going to go through a workshop question that I posed during the workshop, but we didn't have time to go through it. So in this question, we've got a student wishes to conduct an experiment under pH conditions of 4.8. And in their lab, they have the following weak acid conjugate base pairs as an option to make their buffer solution to this pH. And so the question is asking which is the most suitable pair to use and why. So what we do to try to answer this one is that we take the negative logarithm of each of these numbers here to calculate the pKa value of each of these weak acids. So if we do that, just take the negative logarithm of this value and you get 7.46. And then of the middle one of the acetic acid, you get 4.75. And the carbonic acid, you get 6.37. And so based on these values here, we can say, because we want pH of 4.8, the most effective and suitable buffer would be the acetic acid acetate weak acid conjugate base pair. And this is because an ideal buffer solution is when this ratio between your acetic acid and your acetate, which is the A minus, and the HA, which is your weak acid, is closest to 1. And so therefore, the pH would be close to the pKa value. And so this would be where the closest one in value is 4.75 of the acetic acid. Okay, so now onto a trickier part of the question, which is asking from the pair that we chose in the previous question, the student then uses 0.45 moles of the weak acid in 250 mils of water to make the buffer. And we want to know, well, how much of the conjugate base, how many number of moles of the conjugate base do we need to have to complete the buffer so that it satisfies the requirements in B? And the requirement was we want the pH value to be 4.8. So to do this, firstly, we need to convert this number of moles in this volume into a concentration. And so the concentration of our weak acid, of our acetic acid in this base, will be the number of moles, which is 4.5, divided by your volume, which is 0.25, which equals 1.8 moles per liter, or big M. Now we can use the Henderson Hasselbalch equation. So we've got, if I click this, we've got 4.8, which is our target pH. We've got 4.75, which is the pKa value we worked out for the weak acid that we're using. And we got 1.8, which is the concentration of the weak acid. We want to know what concentration of conjugate base should we use? And so to do this, we've got to rearrange this equation to make this A minus concentration the subject. And so we first bring the 4.75 across here. So we minus each side by 4.75. And now we've got so this value here comes to 0.05. Okay. Now to get rid of the log, we take the 10 to the base power of each, 10 to the power of each side. So 10 to the power of 0.05 would equal this ratio between the A minus concentration and 1.8. So if you plug in this into your calculator, you should get 1.12. And now it's an easy thing to make A minus a subject because we multiply both sides by 1.8. And then 1.12 multiplied by 1.8 will give you the concentration needed. And so we need a concentration of conjugate base of 2 moles per liter. Okay, so apologies for not being able to do that in your workshop. Hopefully this will give you the information required that you can answer a question such as this in future.